Welcome to GDG DevFest Day 2 in Wrocław. Is that the pronunciation correct? Yes? Okay. This is my first time out of the United States, actually, so I've learned quite a few things since I've been here. One of the things is how to say the name of the city. So to an English speaker, this name of the city sounds like Wrocław, or it should be pronounced Wrocław, right? But I've learned, as one of my first things here, Wrocław. So, now, the reason I bring that up is because I've learned a couple of things since I've been here, and I hope that this morning I can teach you some things. So we will together teach each other and learn from each other. So, that being said, this talk is Procrastination as a Service, Caching and Queuing. This is a beginner level talk, but it's also, my hope is that if you know about caching, if you know about queuing, it's not just a beginner level talk, maybe it will hopefully change the way that you think about how to implement caching and queuing within your system. So that being said, I would like to thank everybody. There's not an official slide for the vendor to say thank you to the sponsors, thank you to the organizers, thank you to volunteers, but certainly this is a conference that takes quite a bit of effort to put together. And I'd like to thank Bartek and Asia, yes? Asha, yes, and everybody that's here and organizing. Obviously it's a lot of work to go through, so I would like to take a second to just thank everybody. So my name is Shea. I've been a PHP developer. I'm probably one of maybe 2 or 3 of you here at the entire conference for the last 6 years or so. I've worked at Verizon Digital Media, which is a fairly large company within the States, although I recently understood that it doesn't quite have the name recognition here that I expected it to. So, but anyway, I've been there for about 2 years. I have about 100 followers on Twitter, so if you would like to get in before it's cool, I would definitely suggest that you check out So Wizardly, that's me on Twitter. I'm also the co-organizer. If anyone is from the Boston area or would ever like to visit the States, I do organize Boston PHP and Layerville Boston for our local users. And if you ever have a PHP question, more than likely I've at least looked at it on Reddit as on the our PHP help subreddit. So having said that, I'd like to start. One of my very first memories is being bribed by my parents with a turn on the Nintendo if I would just get my winter clothes on. So it was in the early 90s in Western Massachusetts. So the Backstreet Boys were back. The Spice Girls were telling us what they really wanted, and the Nintendo was the pinnacle of consumer entertainment. All right, not the Sega, of course. So I was less than 5 years old, and I learned a very important lesson, and that lesson is work is hard, right? I would say, why would I put on winter clothes now, right? I was all the way in the living room. I didn't want to walk across the house. I'd try and fail to convince my parents that I should procrastinate. I will do this later. The next time I was in my bedroom. So on that note, let's have some rhetorical questions here. So raise your hand if your parents ever scolded you for not putting away your toys. Okay, we got good. Most people here in the room. Okay, good. Yes. All right. So raise your hand if your parents ever believed you when you said you'd made the bed, but you hadn't quite done that yet. Okay, good. About most of the people there. Good. All right. So the last one. Raise your hand if you ever convinced a sibling to do at least one chore for you. Okay. So we've got about everybody in the room has raised their hands at this point. So the point is that as children, we quickly applied the lesson of work is hard, right? We weren't being messy when we didn't put away our toys. Each of us had independently come up with the concept of caching when you didn't put away your toys because they were already out, they're ready to go. We learned to cue our bed making by telling our parents that it was already done, and making a mental note to do it later. We learned how to delegate work to other people so we could free up our brains to do other things. Since our parents seem to have scolded us for developing these useful skills, I'm here to tell you that actually, your parents were wrong. Okay, so these are useful skills, and I will prove it not just by making this point, but actually by showing this picture. Now this is a picture of my family. It's very blurry, but from maybe the What was his dad?
70s.
The 70s. So this is my father here, making fun of him straight up to his face. So this is my dad here. You can see the haircut, the clothes. Clearly, he's made some mistakes in his life, and so I'm here to make that point. Your parents can be wrong sometimes. It's not just computer stuff, by the way, that being lazy and procrastinating is useful. Actually, I will make this other point here. So this is probably the best doctor in the world. Okay, and the reason that I say that is because in 2005, in the Journal of Social Psychology, this is a Dr. Jin Nam Choi, differentiated between two types of procrastination. So there's passive procrastination, which is, and basically in his definition, what you would expect. When you hear someone's procrastinating, this is the lazy person that doesn't finish their work on time and all this. But there's another kind of procrastinator called an active procrastinator, and this is real science. I'm not making this up. He published this in a real journal of science, and in that it says that if you are an active procrastinator, you enjoy that last minute sort of rush, right, to get everything done. So if you're an active procrastinator, you will be at least as good as a person that would normally do it, a little bit every day in academia, like that. So. His results showed that active procrastinators are at least as good as non. So even in academia, it's not bad to be a procrastinator, right? There's actual science here to prove that this is good. So with that being said, oh, nice. That's a pretty busted slide. Okay, so we'll pretend that this looks right. I'd like to play a little game to demonstrate the benefits of doing less work delayed. Can we have two teams, maybe left side, right side? Can we have somebody that's the front end person? You okay? You okay? And maybe some back end people. In the back? Yes? And then you? Yes? Good. You can be a back end person, someone? Okay? All right, we'll work that out later. Okay. So, if you would, please hold this. Please hold this. Now, the goal of this is to show how slow a regular web request is. So what I'd like you to do as a front-end person is to pass this to the back-end persons. We have two back-end people there that are okay with holding. So if you would, pass these envelopes back to the back. Once the back-end person gets it, if you would open the envelope inside. So this envelope will represent, could you read that?
Packet.
A packet. Yeah, it says so on the envelope, so that's how you know it's a packet. So inside the envelope, you'll find a response. So if you would pass it to the back, open the envelope, pull out the response, pass it back to the front, and then once you have the response, if you would say 200, right? Like 200, okay? So we'll know we're done. Now, we're making a point here, so if you wouldn't mind passing it to the back in the slowest possible way. But also you're competing with each other.
Can I use other people, or it's like, can I just...
Oh yeah, pass it, yeah, person to person all the way.
But you like the slower is better, or the faster?
Well, the faster is better.
Okay.
But we're making a point about things being slow, right? Web requests normally, so it's not, there's no price here. So just, pass it back. It's not really competition. So 1, 2, 3, pass it back. Yes, the web is very slow. I am a user, and I am very upset about this lag and delay. About getting my response. I've already left your website. I'm very upset. I will never use it again. I will leave a bad review.
200.
200. Yes. Okay. So for the next time you do this, inside of these envelopes are a response. So that's okay. We don't have to open the response. That's fine. Okay. But yeah, that's good. Point being, regular web requests are very slow. I was the user. This took several seconds to go back to front. I would have left your website. I would have been very upset. I would have left a bad review. This is not, the performance that I would expect as a very sophisticated and, upset user. So, how do we make things a little bit better? Just 1 second. So, the point is, work is hard. So realize that software is just like you, okay? It can get a lot more done when it too negates delays or delegates work. In other words, as software developers, we have a unique opportunity to apply our active procrastination, as the good doctor said. So having said that, I would like to point out, work is hard, do less of it, right? So how do we do that within our application? So I would like to introduce this software. Hopefully you've heard of it. If not, I'm happy to bring it up to you for the first time. This is called Redis. So Redis is a open source in-memory data store. It's written in C. It works as a cache, works as a message broker, which is a fancy way of saying that it's a queue. It has many types of data structures, built-in replication, configurable persistence. It's good for beginners, it's good for enterprise. There are other queues available, not just Redis, but they say RabbitMQ, Kafka, and these are all very good for enterprise and for scaling to high level. But more often than not, if you have some application, there's a good chance that you have Redis installed, just because it's a very good cache as well. So this is kind of free if you decide to also use it for a queue. So it's good for both. So let's play a second game. So the second game, we're going to do basically the same thing, except we have the original response from the front. So I would like if you would just hold on to that, and I'll have you pass 2 new packets to the back, and then when they have them in the back, if you would just say 200 done. Yeah, once they have them in the back. So you already have, you've cached. No, just one, because you're caching. You have the cache here, yes,
So
and then you just pass back the real response.
The response is inside, so
Yeah, that's okay. No, you can just hold it, that's fine. Just pass the envelope back to the back, and then hold on to your cache, and then once they have it in the back, we can say 200 okay. All right, 3, 2, 1, go. All right. So I'm still a very upset user. This is taking a very long time.
200.
Oh, yes. All right. Nice. So, we haven't really established team names yet, so let's pick one really quick. Team what? Oh, on the spot.
Any suggestions?
No?
No.
Team winning, right here. Boom. Okay. And then, so team also winning. Okay, we're here to, we're not, this is not really a competition. It's kind of a competition, but not really. So, as you can see, within this game, obviously the cache was quite a bit quicker. It was at least maybe half the time it took. So you can see that a cache has value. If you cache your anything, any sort of expensive calculation, a response, something like this, it's twice as fast as trying to recalculate that stuff at least. So with that being said, let's talk about caching. So they say a cache is a hardware or software component that stores data so that future requests for that data can be served faster. So the data stored in a cache might be the result of a earlier computation or duplicate of data stored elsewhere. So the point is that a response, some expensive calculation, any sort of anything really. Basically what I'm telling you, the point of this is cache everything. Now you might have to deal with cache invalidation. I don't know if you've heard the phrase in the US. They say there's 2 things that's hard about computer programming. There's cache invalidation and naming things. So later, you may run into those issues, but the point is cache everything. Okay, so with that being said, where is caching useful? So let's pretend that we're building an internal social network for the employees of some company. Maybe we can get a fake company name as well. We did team names. Maybe we can do some fake company name.
Difficult stuff.
Maybe fake company.
Fakecompany.com. Okay, good. All right, so let's pretend that we're building an internal social network for the companies of for the employees of fakecompanies.com. Yeah. So one of the functions of that social network is to suggest new connections by displaying on every page a list of a user's coworkers and their coworkers' coworkers, and of course now let's just add some complexity here. Let's say we're going to do that in alphabetical order as well. And the point of this is just to tack on extra work for our software to do, yeah? So as it turns out, this is a pretty expensive query. So with less than 50 rows, of course, hopefully we're all clear here. This is one table, this is another table, and say in a relational database like MySQL or Maria or something like this. And then this is the ridiculous query that I've written to generate these responses. Now, I'm sure there's at least somebody in the audience that's like a really like SQL pro and is looking at this code and going like, this is not the way to do that. But the point is that this is a slow calculation. This is a slow process. So I'm sure there's a more efficient way to do it, but this is not it. So having said that, with less than 50 rows in either table, the user, coworker, users, whatever, the query speed is noticeably slow. So we know that the HR folks update our coworkers table, say, only once per day. So this is an excellent situation to cache. We'll store the results in the cache and then read from that on every subsequent request for the next 24 hours where we know that the information will update at that point. So having said that, this is a speed test result on my laptop, which is not a particularly performant one. This is a work issue laptop, so these numbers here aren't necessarily like performance grade, like production performance grade, but just as an example, on my laptop, if we call this from the database, which is this blue line here, we can see that it takes on average something like 2.5 seconds or so, something like this, maybe a little more. Now, the red line would be caching it and then returning the results. So as you can see, actually, it's a little bit slower on average to return, to store a result to the cache, results to the cache, and then to display these results to the user. So the first request actually is a little bit slower than just reading it straight from the database. However, subsequent requests, so this is the yellow line here. So after it's been generated, these results, if we just read straight from the cache, it's quite a bit faster. So we have 2.5, 3 seconds, something like this for reading from the database, and then less than 2 pretty consistently from reading from the cache. So that's significantly faster. So actually 24.53% faster in this particular test, with the initial request of about 2.5–3% on average. So that's the question then. So this is a big savings. However, let's talk about what caching looks like a little bit. So this is some PHP code. I know there's like 3 of you maybe that can even read this properly, but I hope that it translates fairly well to other languages. So we have some sample controller with a sample of some indexed response of all the data that we have. So as you can see, this is how this would look normally. So without a cache, just return proposal all, right? But with caching, we're talking about just maybe a few extra lines of code. Just within that all call, you can see here all. Within that all call, we will call the cache, return the results, and then of course, so this would be an example of like how to pull this information from some cache. So that being said, let's talk about cron jobs. So we know that the initial request to the getting this information from the database and everything is a little slower when we go to cache it. It's maybe 2–3% slower. So how can we do this so that every time we're getting that speed improvement, that 2-second, sub-2-second response in the case of my super slow laptop. So we know that reading from the cache is wicked fast. So we can use cron jobs to run the initial query and then feed the results into our cache in the background. Now, it's not always feasible to do that. So in the example we just discussed, we'd need that cron job to feed the query results into our cache for every single user. So maybe your use case is such that you'd rather have a cron job working tirelessly in the background to generate all this data. Maybe you have 1 million users and half of them are active, so you've wasted quite a bit of time. So just be careful about what you do. Like, not everything necessarily should be run on a cron job like this, but I'm just making the point that most of the time it's okay, but sometimes there's issues. So let's talk about another case where caching might be reasonable. So can we cache a leaderboard, right? Suppose that on our internal social network, we want to display a leaderboard style list of the most popular people within our company, i.e. those with the most friends. Now, hold on a second, right? Because leaderboards should be live data, yeah? People change who their friends are all the time. If say the Wrocław office, yes, good. If the Wrocław office decides to all band together with our fakecompany.com and be friends with everyone to game the list and become the top, everyone from the Wrocław office is on the top of the list. Yeah, so we should update this right away. Well, here's the thing. Do you really need this data to be to the second accurate? And this is a question that you should ask yourself when you're working with almost any project. Do you need this data to be live for sure right now? Do you need it? Because can it be slightly delayed? This is a conversation worth having for basically any expensive task you're running, some expensive calculations, some call to the database, anything like this. Can it be delayed? And if so, by how much? So the point is, you probably don't need live data. Okay? I would wager that if you thought about it, either just with you or your team, you would realize that, hey, it's okay for the data to be 5 minutes old, 2 minutes old, a minute old even. Especially if we can have the initial query run and fed into our cache on the background cron job. So again, we're skipping the initial heavier, 2%, 3% increase and going straight to that 2 second, oh, is it done? Oh, okay. Hello? Hello. Yes. Okay, we're back. All right. So again, we're skipping the initial load and keeping all that speed improvement, right? So if you can cache something, cache it, and if you can, cache it on the background queue so that you don't have to do it right then. That being said, let's say that we've done this job. We've cached our leaderboard, and then of course we have praise from our boss. Yes, because we have less load time, the hardware costs are less, and now we can spend time coming up with new features. As our jobs typically will require. Our bosses are very happy with us. We've improved the speed of our networking leaderboard. Our hardware costs are down. Everything, beers all around. Everyone's happy. Yeah. Let's talk about new features. Oh, like this? Yes. Can you guys hear me now? Okay, good. All right. We'll see if I can manage all these things. Okay. So we have praise from our boss. Okay, and we're just moving on here. So now that we have our leaderboard worked out, we have, of course, a new feature. So we come into work on Friday to find that the corporate has decided, hey, we want to sell branded hats, branded t-shirts, flip-flops, handbags, Bluetooth speakers, and those are just the categories, of course, because our inventory of 1 million products is showing up on Monday. Yes, after we've done the leaderboard. So after a few minutes of wondering, like, what happened, like, what you've been doing with your life, like what's going on, the cogs in our brain start to spin, and we know we should do some market research. So, market research. We go on to Zappos. This is oh, okay. We're changing. Okay. Just a minute, folks. Sorry. Oh boy. This is no? All right, we have replacement batteries. Very good. Okay, so we do some market research. So we see that we're going to have to do a lot of work on this new feature. Yeah, we're going to have to make database calls for the menu, for the categories. We're going to have to even make more calls for, like, of course, the now trending and everyday sneakers, all these things. So we're going to have to do quite a few database calls as part of our new feature for fakecompany.com internal social networking site. So with that being said, how we handle this is by full page caching. So we know that our newly incorporated Redis installation, we can cache all our category lists, all these lists and everything. But we can go one step further. We can cache the whole page, and we can even do that with a background cron job. So it works in the same way as caching individual queries or operations. We can just jam the whole page, and maybe the majority of the page, in there and call it when we need it. So now, instead of spending, say, X seconds, 3 seconds or so, for each of the 3 or 4 different pieces of data we call from the cache, we can cut that down by just grouping everything together, jamming it into one database cache call. Well, I guess it is a database, so database cache call, and improving these things. So we've cached, queries, we've cached whole pages, cache everything, just again, going forward, if you can cache, do. And then we finally launched our internal social network / I guess now e-commerce website, yeah? So, to recap, we discussed that work is hard and that we can and should do less of it by caching all the things. So just to be clear, this is actually the reason that I made the talk, specifically just to make this point. Cache me outside, yeah? Anyone seen this? The point is, cache everything, yeah? Having said that, okay, so we've gone past caching, yeah? So weeks have gone by, it's 4 p.m. on a Friday, orders are pouring into our new fakecompany.com application. Users are making friends, things are going smoothly. Our users must be happy because we haven't gotten any complaints, or come to think about it, we haven't got any compliments either, or any communication at all. So the gears are spinning, we're looking over our website only to realize, hey, we don't have a contact form. So how are people supposed to get a hold of us at all, right? So let's create a simple form. We get the contact form built out, we put a simple name, email, message together, get that on a page, get a link to it to the footer, commit that, make a pull request, get it approved and done. Not too bad for 5 p.m. on a Friday, it wasn't too hard to do that. Time to go home. Everything's fine, right? Except everything's on fire. It's 3 a.m. on a Sunday, and the team from maybe the U.S. office of fakecompany.com is getting to work to find that the email address hooked to the contact form is blowing up. Yeah, so we get thousands of product questions. How do I do this? Questions. Just every possible thing you can think of. So to make matters worse, is that when the user clicks the submit button, they don't get a success message until the email is actually sent. Our simple contact form was never intended to handle this kind of load. Requests are taking 20 seconds to complete when they are just outright failing. So what do? How do we handle all these requests? We need to send these messages to someone, and email is only so fast. Corporate is out until Monday, and even thinking about setting up some kind of a distributed email system is beyond us at, say, 3 a.m. on a Sunday as we discover this issue. To the next point, we had work is hard, do less of it, yeah? But now, boom, work is hard, do less of it later, right? So let's talk about queuing. Let's play another game. We're going to do basically the same thing that we did. However, what I'd like you to do is, if you would take these packets again, and the second you pass them back, if you would just say 202 accepted, okay? 1, 2, 3, go.
202.
Yes! Okay, we're done. Wow, that was really fast. Like, I'm a user, and like, I am so happy. Like, this request took like no time at all. This is queuing. We can just tell you it's done and then do it later, right? I mean, this is how we learned this growing up, yeah? We can keep on with our being lazy. So, having said that, why job queue? So, with a job queue, we can queue up a huge amount of messages at a time and then complete them at a reasonable pace in the background on our own time. We don't overload or break anything. Everything's fine. There are some serious benefits to note here immediately. We can respond significantly faster because it's very cheap to add a job to the queue. And if there's some problem completing our task, we can retry it later, and we don't have to show an error message to our end users. So I do want to talk a little bit about the status code. Now this is, aside from I'm a teapot 419, this is probably my favorite status code, so 202 accepted. I'm just going to read this verbatim. The request has been accepted for processing. but the processing has not been completed, the request might or might not eventually be acted upon, and it might be disallowed when processing actually takes place. And this is the actual definition of this response code. So basically, this is straight up lazy procrastination response code, 202. We'll do it later. It might not work, but for now it's fine. Yeah? This is basically just perfect for us here for procrastination. Yeah? So let's talk a little bit about which package. Yeah? So you can once we have our jobs in the queue, we still need to process these queues. So we'll need to add a queue processing library to our database, and this is built into or easily integrated into frameworks in many languages, right? So I'm a PHP guy, so of course we have our PHP queue, but if you're a Python guy, JavaScript guy, or any sort of, like, you can just go on GitHub, look up queue, and there's like a package for everything. It doesn't matter, Kotlin or anything, it's fine. So I would definitely suggest checking some of these out if you happen to be PHP, Python, JS guy. But let's talk about how fast job queuing is, right? So, like in our example, how fast is it to literally do all the work in the background and later? Well, with the typical contact form, we're going to need to send like 2 emails, right? One to the user saying, "Hey, we got your email," and then one to the end user that will handle these emails. So, again, now just for the sake of making the point. I've done this test with actually sending 5 emails, not 2. Suppose we have some friends or coworkers or something like this. So to actually send 5 emails from my laptop, it takes about 8 seconds. So that's wicked slow, like 8-second response time, which is not fine for anybody. But if we queue this job, that same request takes about 2 seconds to respond yes, 202 accepted. On my laptop, so you can see it's a pretty serious difference in speed. So we were able to decrease time spent by about 73%. That's a big savings. So we implemented a job queue for the contact form, and suddenly things are working as they should. People are happy. We are getting performance. Everyone's getting their emails. Everyone's winning. So here's an example. Oh, this is pretty warped. Sorry about that. But this is actually some production code for my job. So what we do is we listen for several events to go off, and then when these events go off, we actually dispatch a job to generate a new XML file for our machines. So you can see here, we listen for some event, and then when we hear it, we fire off some job. So this isn't crazy code. Like, this is pretty straightforward and simple, I think, for most folks to read. So it's not super difficult to get a queue in place. And then this is some more code here. So we got the actual handling of the job. So we accept the data, get it all stored, and then when we handle it, we of course actually go and do the job there. So that's what it looks like. So we've implemented a queue. We have praise from our boss. We have a much faster response time, happy users. Even better than the perceived performance is the fault tolerance aspect of job queuing, which I want to make a point. So fault tolerance. I really can't stress this enough. Almost anything that could go wrong, we can just retry it. So message didn't send, the database is offline, bug makes it into production, 202 accepted, that's it. And we'll try again later. So no user gets an error message with queuing. So now that we've implemented queuing, what else can we queue? So just to make it clear, I'm literally telling you that you should queue all the things. So I'm challenging you to find something that can't be queued and then figure out how to queue that. So having said that, to recap, we talked about we should cache things when we can, do work later always. Now, there's probably a few smart people somewhere in the audience here that are absorbing all this and thinking to themselves, hey, there's a limitation to queuing. As I've described it so far, it's only really going to work when we don't need to respond to the user with anything particularly useful, because we're just responding to the 202, we'll do it later. So it's pretty generic. So let's see an example of how we can overcome this limitation. Let's say that we are going to build a to-do list into our social network e-commerce system. This is a pretty typical example for most things. And we want to queue the addition of a task to the list. If we do the job later and the user refreshes their browser, suddenly we have a confused user. They didn't get an error, and yet their to-do app isn't updated with the task that they just submitted. Something must be broken. Spam that refresh button until something happens. Call customer support. Never use the site again. Right? But there is a solution to this problem of queuing jobs in and later and then still responding to the user with something valuable, and that is WebSockets. So just again, a verbatim reading here. WebSockets is an advanced technology that makes it possible to open an interactive communication session between the user's browser and a server. And with this API, you can send messages to a server and receive event-driven responses without having to poll the server for a reply. So that's WebSockets. So I'd like to play one last game, just to really hammer the point home. And again, that's a pretty sweet broken slide. To really just hammer the point home of like how great WebSockets are. So if you would, if you could grab these once more, one last time, and pass those to the back. And then once the back-end person gets it, if you could just take the response that's inside the envelope and just chuck it at me, so we can make the point about WebSockets. Okay, so 1, 2, 3, go. All right. So 2 and 2 accepted, so we're good, yes. I've received some response, but now as a user, I've noticed that my change that I submitted did not quite make it to the website. So now I'm wondering, hey, how is this, what's going on? Is there some response that I can receive? Maybe from the back somewhere? If we could just ball that response up and just chuck it up here. There it is. Yes, I have received a response. Almost, yeah, that's fine. So the point is that you can queue jobs, you can respond with, yes, it was successful, the user is satisfied, and then several seconds later when they start wondering, hey, what's going on, they will have a response and everything's fine. So, where is my clicker? There it is, okay. So which package, yeah? So there's quite a few packages. I've put these out there for PHP, JavaScript, Python, but of course we have a lot of Kotlin folks here, a lot of mobile devs. But for sure, if you just want to get up and look up, WebSocket package, you will find something. And so having said that, let's look at an example of some WebSocket production code. Again, this is at my job at Verizon, we use WebSockets every day. And so we just fire off an event, and we submit some data to that, and then that's it. So actually, very simple. It's not scary code. This is fairly simple and straightforward. It's something easy you can add to your project at any time. With that, I will just say that no matter where you are in your coder journey, it is never too late to improve performance by being lazy and actively procrastinating. So with that said, this is Procrastination as a Service. My name is Shea, and any questions? Going once, going twice? No? All right, thank you.